So then we just saw in the last video how we can kind of make these custom types using something called interfaces. But there's also another way to make custom types by using something called a type alias. And in many ways it's similar to an interface, but there are some subtle differences which we're going to go over. So the way we define a new type alias is by saying type, first of all, and then the name of this custom type alias. So I'm going to make one called RGB, which stands for red, green, blue. It represents those three color codes, right? And when we make a type alias, we set it equal to the custom type using the assignment operator. Now this is different from an interface, which has no assignment operator. With an interface, we just open up our curly braces straight away. But with a type alias, we set it equal to the custom type using the assignment operator, all right? So now we can define any kind of custom type here. So for example, I could set this type alias to be a tuple, which has 3 values inside it, all numbers. So number, number, and number. And then if we wanted to, we could use that type alias for things like function arguments or return types, or even just defining new variables. So let's do a quick example. So let's create a new function then, and this function is going to be called getRandomColor, like so. And it's going to return this type, RGB, which is this tuple right here. So it has to return this tuple with 3 numbers inside it. So let's inside just paste in this little bit of code. So I'm creating 3 constants, one for R, one for G, and one for B. And basically each one gets us a random number between 0 and 255. So when we have an RGB color, all the numbers are integers between 0 and 255, and that's what we're going to get here, 3 different numbers, one for red, green, and blue. So now though, we have to return a tuple. So we can say return, and if we return any old value like true right here, it's not going to work because we have to return this specific tuple right here. So instead, let's return R, and then G, and then B. And now this will work because those 3 are all numbers. If one of these wasn't a number, for example, string version of 30, it's not going to work, alright? So that's an example of creating a custom type and using that custom type as a return value. Also, if we try to invoke this function, for example, if I say const color1 and set that equal to getRandomColor, like so, then if we hover over this, you're going to see that it infers the type RGB because it knows that this returns RGB right here. Okay, so let me do another one. I'm going to say const color2 is equal to getRandomColor, like so. And I'm just doing this so that we can log these to the console.log. And then it's going to be color1 and then color2. All right. So then now if I open up a terminal, we can see both of these and we get 2 random RGB colors. Pretty cool, right? Okay, so now let's move on to another example. And in this example, we're going to create a type that describes an object. So let me now create a new type down here. So we say type first, then the name is the type, which I'm going to call user. Then we set it equal to something, and then it's going to be an object. So curly braces. Now inside this, we're going to have a name property, which must be a string, and then also a score property, which must be a number. All right, so let's do that. By the way, we don't need this comma right here. Okay, so this looks very much like an interface, but we have this equal signs right here. Okay, so down here, we can say const user1 is of type now user. And we can try and set it equal to something. So it has to be an object and it has to have these 2 properties, name and score. So if I say name is going to be Mario, and then the score is going to be 75, then that's fine. There's no errors because now we have both of those properties and the values are the correct types. If we add something else here, for example, age 45, then we get an error right here to say that this doesn't exist on the type user. So we shouldn't be here. All right then. So now we have that object. Let's also create a function which accepts an object as an argument of type user. So let's come down here and say function format user. And this is going to take in an argument called user, which must be of type user. All right, so it's not going to return anything, which is why we'll say void right here. And then inside the function, all I'm going to do is log something to the console. So template strings or backticks. So we can output variables, $, curly braces to output a variable, and then we can say user and then dot. And then we get these options right here, and we get these because TypeScript knows that we have these 2 properties on the user. So it gives us that good code completion. So I will say name first of all, and then we'll say has a score of, and then $ curly braces again, and this time user dot score. Cool. So now we can revoke this. I will say format user, and we can pass in user1, and that's absolutely fine. If I say format user down here and pass in an object, then that object must have these properties right here. So it doesn't have to be stored inside another constant somewhere. We can do it directly as an object literal here. So we could say name is Yoshi this time, and then the score is 100. So this works as well. But again, if I add on something else like the age, then this is not going to work. It's not going to let us do that because age shouldn't be here. All right. So let's give this a whirl. I'm going to save it and open up the terminal, and we should see these two sentences. Mario has a score of 75 and Yoshi has a score of 100. Cool. So there we go. That's another way we can make these custom types using the type keyword. And we set it equal to a custom type, and that type can be pretty much anything. Alright then gang, so we've let a few different TypeScript features now, which hopefully you can see the benefits from already. And now I want to introduce you to another TypeScript feature called union types. And union types are a way for us to let TypeScript know that a particular variable or value somewhere can be one of several different types. For example, I might have an ID variable, which I'm just going to call, I don't know, some ID for now. And I know that that ID could either be a number type or a string type in the future, right? It could be one of those two things. So I could make a union type to describe that or to declare that. And the way we do it is by adding our colon as usual, and then saying number, and then a pipe symbol, which means or, and then string. And this right here is known as a union type, where we're saying that this variable can either hold now a number or a string. So now if I come down here, I can say some ID and set it equal to an actual value, which is a number 1, and that would be fine. Or I could say some ID is equal to a string, which might be 2. That would be fine because it could be either a number or a string. Alright then, so let's do another example. I'm going to say let email be either a string or null. So I want you to imagine that maybe we have some kind of application where a user logs in and we have this property, which is the user's email. And that might only have a value of a string when the user's logged in. Otherwise, it could be null. So this is a case where we might use a union type. So I could set it to be null originally as the initial value, but I could change it when a user logs in maybe to have a value. So I could say email is now equal to Mario. If we can spell it, that is mario@netninja.dev. And that would be fine. And then if they log out, I could reset it back to null, because it could be one of these two types. Awesome. So now let's create an actual type. So we saw type aliases in the last video, and that's what I'm creating here, a type alias of ID. And I'm saying that that could either be a number or a string, because typically IDs might be a number, or they could be some random string like this kind of thing, right? So that's one idea, this type alias right here. And it's just a quick way now of saying whenever we have an ID, just use this type alias instead of writing out this union type over and over. So let me come down here and say let another ID be of type ID, right? And then below that, I can say another ID is equal to some kind of string. So some long ass string like that, and that would be fine. I can say another ID is equal to 5, a number, that would be fine. Awesome. So these union types are pretty useful and quite flexible when a value can be one of a number of different types, but there is a little pitfall that you have to watch out for. So let me just come down here and I'm going to uncomment all of this stuff right here. So I've got a function here called swap ID type, right? And it takes in an argument ID, which might be a number or a string, because remember we just created that type alias, alright? And it returns either a number or string. So what we intend to do inside this function is if they pass in a string, then we'll change it to a number. If they pass in a number, then we'll change it to a string. Now imagine I pass in swap ID type. Let me just write this out. I pass in a number, right? Now, how do I know inside this function that I passed in a number? Well, I don't, because ID right here inside this function can either be a number or a string. So if I try to say something like parse, if I would take this in as a string, so 5, if I try to say parse int and then pass in the ID right here, then I get an error. Now, we should be able to do that with a string. If I pass in 5 as a string right here, it's going to parse that into an integer and we'll get back the number. But because TypeScript doesn't know that this is definitely a string right here, then we're not allowed to do that. Alright, so when we pass in a union type into a function, we can only use props and methods, which are common to both of those types. Now, parse int, we can't use on an actual integer. That just doesn't make sense. So, because it's not common to both of those types, number and string, we can't use it. Okay? So, there is a way around this using type guards, and we're going to talk about that in the next lesson. Okay then, so we saw in the last lesson that there is a pitfall we can stumble into when we're using union types, whereby if we're telling the TypeScript compiler that a value can be one of two types, then we can only use methods and properties on that value, which are common to both types. Because if we try to use a method specific to one of the types, but then we pass in the other type as an argument to a function, for example, right here, then we'll get a runtime error. So if you want to use methods or properties which are unique to one of these types, then you need a way to tell the TypeScript compiler what type for definite that we're working with. And the way we can do that is by using something called a type guard. So a type guard is just a fancy way of saying that we're going to check the type of something before trying to execute some code. For example, if I want to check the type of this ID argument right here, I can do to see if it's a string or if it's a number. Before I try to execute some code, you need to either type. So the way I can do that is just by using a simple if check to say if, and then we'll say the type of ID, which is the argument, is equal to string. Then we want to do something, right? So this is how we make a type guard, and TypeScript is really clever. It knows now inside this code block, inside the if statement, that the ID can only be a string at this point because we've checked it. So it lets us use all those properties and methods now specific to a string, which is awesome. We can also tack on an else clause as well to run some other code. And again, TypeScript is really clever at this point, and it can deduce that the argument wasn't a string because we've bypassed that code block. So therefore it has to be a number because that's the only other type the ID can be, because we specified that inside this argument section right here. So inside the second code block, inside the else statement, we can use anything now specific to numbers. Alright, cool. So let's flesh out this functionality then. So then right here we know that we can use string methods and properties. So we want to turn the ID, which is currently a string, into a number, and we can use the parse int function to do that, because that takes in a string version of a number and turns it into a number, right? So now we're returning a number for the ID. Cool. So down here we can use number methods and properties now because we know the ID is a number inside this else block, so we can return now the ID and then use the toString method on it to turn it into an ID version of that string. So we're now swapping the type of ID, right? So let's try this out. I'm going to say const ID1 is equal to, and then swap ID type. To invoke it, pass in a number, which is 1. And that should return a string value. Then say const ID2. Set that equal to swap ID type again. And this time we're going to pass in a string, which is 2, and that should turn it into the number 2, right? Cool, so now we have these two functions returning these two values. Now let's log them to the console. So I'm going to say console.log ID1, ID2. Alright, so then now we can save this and preview and we see 1 and 2. Now where we have a yellow number, that is an actual integer, and where we have a white one, that's a string. And now there's no quotes, but believe me, the yellow is an integer and the white is a string, so this has worked. It's swapped the types of the IDs. Cool. Alright, cool. So let's try out another example using interfaces this time. So I've got two interfaces set up, one called user, another called person, and they both specify a bunch of different properties for those types. Now I also have a function called log details, which takes in an argument called value, which must be a user or a person type, and its return type is void. It doesn't return thing. Now again, because TypeScript doesn't know at this point what type exactly will be passed in as an argument, it could be either a user or a person, right? Then we only get access to common properties between both of those interfaces, and the only common property is an ID property, which isn't much use on its own ideally. We want to find out the data type passed in, so we can access all the properties of each type if we need them. Now, unfortunately, we can't use typeof like we did before to check interface types. So instead we have to figure out another way of checking the types. And one way to check them is by using something called a tagged interface, and that basically means give each interface a common property, something like, I don't know, type, or you can name it something different, which is hard-coded into the interface. So for example, the type for this interface would be user, a string user, right? And then we could add a type property in the person interface, and the value would be person as a string. And since this is a common property for both types, it has different values, right? But since it's a common property, we can access it inside the function regardless of which type is sent in as an argument now. So we could set up a type guard to check that property, that type property, and then TypeScript would be clever enough to work out which type was passed in based on that check. So let's flesh this out. So I've already said right here, if value.type is equal to user, then do something, and TypeScript knows now that within inside this code block, the value has the type of user because of this type property being equal to user. And so therefore, we're going to get all the options associated with a user, all the properties, email and username, these two right here. So let's log those to the console.log, value dot, and then it's going to be email, and then value dot username. Alright, so let's do another if check. We'll say if value dot type is triple equal to person this time, which is what we said right here. Then do something else. And again, TypeScript is pretty clever. It knows now that the data type of the value it's dealing with is of type person, because it checks the type property right here to see that it's a person. So now I can say console.log. And inside here, we're going to get options available to us, which are first name and age. So we have put the first name and then value dot age. Awesome. So there we go, my friends. That's how we use type guards up here using typeof, and also how we can use tagged interfaces with type guards as well.